Welcome to Mock It. Liz is a user experience strategist turned project manager committed to human-centered driven approaches and results. She has worked on 20-plus higher education, government, and client-facing websites and software platforms, creating long-lasting, user-focused digital solutions. Liz is devoted to equity and strives to celebrate diversity and inclusion in the industry and beyond. Marie is a former visual designer turned agile-loving, human-centered design advocate. They have helped government organizations for almost a decade build successful digital products by aligning cross-functional teams around a deep understanding of the user at the heart of their mission. Marie is passionate about improving user experiences while achieving business objectives in harmony. They are also a strong advocate for women in STEM.
Hi, I'm Liz.
And I'm Marie, and this is Mock It, a podcast sponsored by MetroStar, where we take a deep dive look into design, trending design topics, and chatting with our friends in the field. Let's get started.
Awesome. Thanks for that intro, Marie. So for this portion of the episode, we're going to talk about some industry updates, give some shout outs to some articles that we've read, and then also I want to give a nod to the 4th anniversary of the IDEA Act. So for those who have listened to our previous podcast, we actually talked about this, I think in season 1. Mm-hmm. So the IDEA Act is the Integrated Digital Experience Act, and the goal aims to improve the digital experience for government customers and reinforces existing requirements for federal public websites. So basically, in short, making sure that any government website is accessible to all, and making sure that goes from having the technology to access it as well as the language on there, and reducing any accessibility barriers that people might need.
Mm-hmm. So, right. And it's where the president's management agenda, right, is like born out of. It's the continual policy making to continue this forth.
Exactly. So that's been, it's great that it's gone on for 4 years. It's spanned different administrations. It's something that has been across the spectrum effort. And then it's trickling now down to all of the agencies across the government. So it's super cool.
Yeah, it's fantastic.
And then I'm going to hand it off to you to give one of your updates with some cool industry tips.
Yeah, so I have for today 5 tips on managing stakeholder and subject matter expert feedback. So right in human-centered design, we're very focused on our end users, which it's great. And then sometimes you need, depending on your topic, so like for my project's topic, I need my stakeholders' input. It's a very specific niche of what they do. It's not a very common thing that you would come across. So unless you're in that field and working in it, right, I don't know the industry-specific knowledge, and I've had to learn it. So while you go through human-centered design and you're focusing on your end user, it's also really good to hear back from your stakeholders and your subject matter experts. And many of the times when we win work, these folks have been dealing with those problems for a very long time, right? And they are working with their end users, and they have pains that are valid, and they've helped us produce other types of research methods. Like we've done hypothesis-driven design before. That's been really helpful. But the 5 tips for managing feedback with them is, 1, to be really clear and specific with what you're looking for. You want to make sure, right, none of them have experience in what you're doing. So you want to just have clear, succinct information up at the top, make it brief, make it scannable, right? Because they are now your end users too. So, right, everyone wants it quick, easy, accessible. You want to be very clear about your process and what you're looking for. So, right, that they're not like, oh my gosh, what is this? I've never done this before, that they have a lot of questions. Give them like 3 quick questions that you need them to evaluate whatever thing that you've given them. Third is and this is actually very timely for me. It's been really helpful for my stakeholders and my subject matter experts to have an iffy line to cross, or like to say, I forget how I say it now, but like can I have this feedback back no later than by. They really like the no later than by. I feel sometimes it's very abrupt as a contractor, but folks seem to be responding to it. I would say my best practice is at least a week, depending on the size of the task. And then, so that is the third one. And then the fourth one is just, it's like any relationship. You gotta be respectful, open and available for them if they have any questions, and then continue to build that relationship going forward. Because then the feedback will always just get better. And then the fifth is just being thankful for their time and their participation to help you. So
I love these. I feel like, we've done a lot of user, we've reached out to a lot of users to get feedback and done testing, and then we've done it through email as well. So these are all really great, and especially people can be nervous.
Yeah.
Like, we're used to it because we're in this field, and it's like, just have a conversation.
Right.
But breaking that ice is not always the easiest. So I love these, and definitely meeting people where they're at and then creating that like safe zone for them.
Yeah, trying to give them guardrails for them to be successful. Because like you said, right, we've done like millions of interviews and different test methods, but this is their first time, and who knows like how often that they do it.
Exactly. And then they're probably like, who are you?
Right.
Like there's not that previous, in a lot of cases, there's not that previous relationship. So it can be kind of a relaxed conversation. It's more, you kind of have to, I find sometimes with these interviews that people are a little stiff at the beginning. And then like once they're like, you're not judging me, you're judging X, Y, Z. Yeah.
I mean, in theory, I'm judging myself. Right. In theory, I'm asking for open criticism of what we've just created or proposed.
Yeah, that's true.
So
people want to be mean, I guess. So awesome. Yeah. Well, thanks for sharing those.
Yeah.
So for today, we have a really exciting guest, Wilson. Thank you for joining us. You were once an intern at MetroStar, and now you are the company's senior data scientist and computer vision practitioners. So
say that 3 times fast.
I know. I was like, wow, this is a very impressive title you have. So you create cutting edge technologies to improve government agency strategies, and your specialties are big data, predictive modeling, and computer vision. Thanks for being here. And would you take a minute or two to introduce yourself and let our listeners know more about you and what you do?
Sure. Thanks for having me on. So I'm Wilson, data scientist, senior data scientist with MetroStar on our R&D side of the house with Team CSG. A little bit about how I became a data scientist. I started out actually, after my undergrad, I went into sales because I was a business major. And throughout the years, I worked a lot with data. I worked for a lot of tech companies like CDW, Gartner, and LinkedIn. And every year we would have to scrub our books of, good and bad contacts. And, one year I got, I think it was like 12,000 contacts that I had to scrub through. And I was like, that sounds a little ridiculous. So I figured out how to solve that programmatically and got a clean list and a dirty list, went through and scrubbed those by hand. And that was when I was like, well, that provided value to me and or the business. I was like, that's got to be a full-time job, right?
It kind of works smarter, not harder.
Yeah, I was like,
nice.
I like doing that. And I was like, so how do I get to do that for 40 hours-ish a week, And so I ended up going back to school, getting my degree in data science, and now we are doing these things, which are slightly more complicated than some Excel functions, but yeah.
You got to start somewhere, right?
Yeah, exactly. So thank you for being here. And then, so to start some of our interviews, what we do is we do a rapid fire question session. So we're going to dive in. All right. So what is AI and ML?
Sure. So artificial intelligence, AI, is simply the act of automating some form of intelligent decision-making. Typically, we consider that human intelligence, but at the same time, want to kind of distance AI from that in general, because there's intelligence in species outside of humans. For example, like you've heard of the slime mold that's able to solve the traveling salesman problem, where it recreated the Tokyo subway system from an experiment. So that's a really interesting article if anyone wants to check that out.
I was about to say, I need this link afterwards.
And then, so there's a lot of intelligence that exists in the world outside of just humans, but a lot of people think of it as human intelligence. But we can learn a lot from other species. So anyway, AI being intelligent decision-making by machines, and that can be either programmatic or, statistics, mathematical. And then machine learning, on the other hand, is typically learning specifically from data using statistics and, the more of the predictive modeling side of the house to figure out and learn patterns from data. So ML being that subset of AI that deals with the statistics side of the house.
Awesome. And can you give us a little bit more background on what big data is?
Sure. So big data is super simple in that it's just big data can most easily be described, as I have trouble saying it, as enough data that doesn't fit on one machine, right? So if you need multiple machines to use that data in memory, that should be considered big data in some way, shape, or form. And the ways to solve for that are really a couple of ways, one of which is get a bigger computer, which means, set up like a distributed compute system, or of course you can just read in less data. So you read it in by chunk and you work with like little pieces of it until you've dealt with all the data as I smacked the microphone.
Sorry, it happens to the best of us.
Too expressive. But yeah, that's big data.
And then what is predictive modeling?
So predictive modeling is we want to try to figure something out, right? And we've got some historic data that in the past we were able to figure out whether or not something in the future was either going to happen or something is happening based off of past data. So we're able to use these historical analyses to predict what will happen in the future. And so predictive analysis is essentially, we withhold some information from the model and try to figure out from other aspects of the data what is happening with that thing that we withhold, because that thing that we withheld is the thing that we care about.
I feel like this is going to be a very interesting interview as we continue going on. And then last rapid fire question is, what is computer vision?
So computer vision is essentially how we work with images within a computer. So that's how images can be represented as math at the end of the day and understood by computers, because we as humans, we have the advantage of a really powerful processor that exists, behind our eyes here, that's had millions of years to evolve. And, machines are just like, hey, here's some CPU, here's some GPU, figure it out. And so computer vision tries to be able to break that down mathematically to the point where the computers can perform, tasks that it would take, sometimes a human to do. But since it's a computer and it's got one singular focus, typically it can get through stuff a little faster than we can.
Nice. It frees us up to do better stuff.
More interesting.
Yeah, more interesting.
Awesome. So it's no secret that AI and ML, so we're trying to be more accessible with some of our acronyms. So if you say any new acronyms, let people know what they mean, or I'll jump in and ask.
Definitely stop.
I'll be one of those people. So yeah, it's no secret that this new set of technology, some people are worried about it for the future. What are some common things that you've seen or heard that prevent people from trusting this new era as we move forward and technology advances?
Sure. I mean, it's totally fair where something like this could be used for ill gain, right? Like, but that's, there's an entire group of people out there, on the data science side of the house who are working actively to ensure that that doesn't happen, right? Like that we apply ethics and keep, personal, like, we want to ensure that people are helped by these technologies rather than like, something more nefarious, right? I was like, I could use, some joke analogies here, but that might not be great. But, we want to ensure that things are used ethically and that we're creating things that make people's lives better at the end of the day. So, some of the things that can freak people out, though, is, when there's bias in algorithms, like Apple's facial recognition technology, for example, where there's obviously a large degree of bias where there was an issue with people being able to unlock other people's phones of, that had an Asian nationality. And so that was obviously an issue with their bias where people could just unlock each other's phones in that regard.
Yeah. That's so funny you bring that one up. We just recently, not to like give out too many personal details, a connection of mine who her children were using the phone. She only did facial recognition for her youngest child, but then all three of her children can actually do it. And I guess they look similar enough, but they're not like identical twins. And they're ranging from like much younger to like a 12-year-old. Yeah. So right, you even think about like just the changes in our faces over those years, and it's wild that she was like, now they just all get it.
I feel like this is a parenting hack. Like, do not set that up.
Yeah, the passwords I would rely on more so than the facial recognition.
Yeah, for sure.
So how do you think we go about building trust with those who are kind of a little bit skeptical, one in the government sphere of how we increase this technology within the government sphere, and then also, private use?
Yeah, or even with the end users of it, right?
Oh, yes.
So there are two ways that we try to approach it. And as you mentioned with the end users, we try to keep humans in the loop, right? Where humans are able to validate whether the AI ML is making the proper decision or not, identify biases, and essentially help keep the model correct for the long term. That way we don't end up with people's phone being, unlocked by their entire family.
Right. Not good.
And hopefully we can help it identify, hey, that was wrong, penalize it for being wrong, and then correct itself over time. The other way is we want to try to improve on things like explainability for algorithms. So what that means is a lot of deep learning models are relatively black box, right? So what that means is you can't really tell why it's making a decision from a mathematical standpoint, even though it is all math. If we were to sit there and write down the equation, it would be just an absolutely insane equation to try and visually understand. But what we can do is we can trace back and say, why based off of the original thing that it looked at, it made a decision, and kind of show where it activated, where neurons lit up. And then that way the user can say, this thing thought that this husky was a wolf because there was snow in the background of the picture and it picked up on the snow. So using explainability and keeping humans in the loop can help solve some of that.
Nice. I want to touch on, you talked about the biases point. So in design, we talk about being aware of that in our designs for experiences, and how we address that is there's a big push about co-creating with your end users to help inform that. And then also just having a diverse group with you while you're creating both. Oh my gosh, how do I say, I want to say this the most PC, both I don't know, your ethnical representation, but also what you focus on. So a designer, a developer, whoever around, because we all come from different walks of life, different perspectives. How do you help an algorithm not be biased?
Great question. And realistically, there are a number of ways to examine it. One of which is, the model's going to learn whatever you tell it to learn. And the big challenge there is that any biases that exist in your data set will be surfaced by the model, right? Because it's going to learn those biases.
Okay.
So, for example, one of the things that you don't want to include in a fraud detection algorithm is, zip code, because there are, issues with different ethnicities living in different neighborhoods, and that can lead to bias existing within your model, where you may detect fraud based off of a zip code, and that's not an actual predictor, right? Or it shouldn't be taken into account. So using just intelligent experimentation methods and understanding where there may be some bias leak, and then also exploring your data sets. So if you're noticing that is a predictor, for example, maybe go in and see if there's any alternate feature, I guess, that would explain some of that, or maybe there may be bias on the human side of things, right? And that's just something that the model will pick up on. And at the end of the day, it may be more of a process, more of a issue of examining the actual process that's happening, more so than trying to make a model that'll automate that process. Because if the process is flawed and we're automating that process, then we have a problem.
Yes, then you're automating a flaw. No good.
So then, to spin this a little bit more on the positive side, what are some things that people should be excited about with this new technology, especially in the government, for government agencies?
Sure. I mean, the thing that I always use as the example is, there's a lot of work out there that people are doing right now that, we want to be able to make that a little bit easier. Like, for example, my 12,000 names, right? I was a salesperson. I probably shouldn't be combing an Excel sheet for 3 months trying to find what the good names and bad names are. Versus on the flip side, let's say you're a security guard, right? And you're sitting, we're in that old movie trope where you've got some teenagers breaking into a facility and you're sitting there, it's 3 a.m. You just finished your delivery pizza dinner, and you've passed out in your chair and these kids just scamper on in and you have no way of knowing until they set off an alarm. Well, using computer vision, TM, not actually TM, but using computer vision, being able to set it up so that if it detects someone that's maybe not in uniform on a base, or, someone didn't buzz their badge and they went through an area where you're supposed to buzz your badge, you can have an alarm set off on the thing for human review. And then, maybe that wakes up the guard at 3 a.m. who, otherwise would have missed those people. And so it's more of helping people do their job more so than replacing jobs. Because at the end of the day, I don't want to sit there and review 8 hours of video footage if instead I can just look at an Excel sheet that says people went in and out of the building at these 6 times over the course of the last 6 hours.
Is that similar for a timely event? The World Cup was using data points to do offsides. Is that similar to that, how the World Cup was applying the data points of all the players and everything and the ball?
So I am not aware of that, but I haven't done any research on that one, so I can't say yes or no on it. But that would be an interesting application. I know that sports like there's a lot of analytics that's being used nowadays across all the different sports, everything from baseball to golf, right? I guess I shouldn't have picked 2 sports that hit balls with sticks, but different size balls and different size sticks. So
that's going to be the clip. Yeah.
There we go. Great. So when we're looking at computer vision analytics and things like that, when it's in regards to sports, there are a lot of different ways that we can help improve on performance and things like that. But the one thing that I want to make sure that we always do is kind of continue to experiment, because if we rely too heavily on like how things were done in the past, and that's a lot of what can happen with, if you're using predictive analytics or using historical data, that's great. But we've got to make sure that we're still experimenting to try and find something, new in that space. And, at the end of the day, I think that's realistically what all the data scientists out there are hopefully doing, but, that's a little bit of the space that we do, is just kind of exploring and trying to find new stuff that sounds fun or could be useful.
Cool. Yeah.
I thought that was a great pop culture reference you made. I'm like, I should look into that too.
Yeah. Well, it's actually on our in-house corporate, trying not to say things, our in-house corporate messaging system. Jorge dropped a link in about it, so it's pretty cool. And again, the humans were not taken out of the picture. It was just to help them, review and make that call to review it sooner, kind of like the security guard. Like, it's helping the job happen. It's making the play of the game and, that experience, which is more enjoyable for the fans, go faster than like waiting those like 5 or 10 minutes for the reviews. And you're like, come on, let's get back to the game. But I understand why they're doing the calls.
I have a question on that. I mean, that's probably not the right question to ask, but I wonder how they do that without creating bias.
What do you mean?
Like, I don't know if they wanted the,
there's actually like a thing in the ball. I say thing because I don't fully remember the article, but they're sending data, sending like millions of data points every second to the computer. So the ball has a thing in it, right? I'm so technical, to know where it is on the field, and there's like 1 million points on the players, and then they know where that line, like they can make a line. And it's crazy because it's even like a hair, like if my elbow is a hair like further in front of the defender, technically offsides before the ball was played. So it's like an even more accurate game call to be reviewed to call it.
Oh, that's cool.
Yeah.
I have to brush up on my soccer rules.
Yes, right before you get into your youth sports.
Oh, yeah, exactly. I'm like, there's only 2 sports we know about, basketball and volleyball.
Good ones. Yeah. They're good ones.
So we talk a lot about human in the loop at MetroStar. Can you give us a couple sentences on what that means?
Sure. So it's pretty simple, and it's named after what it does, right? It's keeping humans in the loop, where we're not going to just take the AI and be like, hey, fly this plane, right? Even Tesla's self-driving car, they recommend, they recommend and or tell you to keep your hands on the steering wheel and pay attention to what it's doing. And the reason for that is, right now it's not perfect, right? Mm-hmm. There are a lot of factors to take into account when it comes to doing something that we take for granted, like driving, because we are beings that are given a lot of, we have our senses that we're able to work with. Meanwhile, we're still kind of sorting out how to translate that into the machine learning decision-making process. So at the end of the day, human in the loop is there to provide the model feedback and ensure that, whatever the model's tasked with doing, even when it gets something wrong, the human's there to kind of course correct it. And that's at the end of the day, what we're talking about with just making your job easier, not replacing your job, right? Because, like for example, one of the clients that we work with had some work that they used to do where they had hours and hours and hours, and I mean a lot of video footage. And a lot of the times what would happen is someone would say, hey, we think that something happened between this and this time frame, maybe like a wide time frame, right? And they'll have to go back through and watch the entire video and try and see if they can figure out if and when that thing happened. If they can find that, they've got to then figure out what caused that thing to happen from some other data that they had access to. So we built a system that was able to identify event occurrences and then trace that back to some sensor data, kind of like what you were talking about with being offsides in the soccer ball. And in this case, it's more of, we're able to identify an occurrence in video, fuse that back to some sensor data and say, okay, event happened here. What are the events that led up to this thing? Can we identify that event in a series of other data rather than then, because what they would do is they would find that event and then go and try and find it in other areas. And that would just take months. And now it can be done in you can have a prototype in a week, which is fun.
Right. So just removing watching all that video play.
Yeah.
To do better stuff with your job time.
Oh, that's awesome. And then I know there's a big fear that, and you've touched upon this as we've gone through, that machines are basically going to replace humans. But can you touch upon how humans are vital to the role of the advancement of AI and ML?
Yeah, I mean, at the end of the day, there are some applications of AI that could offset jobs, right? Like with Chat GPT and chatbots and things like that, as well as Stable Diffusion, which is the thing where people would type in a sentence and it would output an image, right? There are some things that exist out there that could be used to offset jobs, but at the same time, they're going to do things based off of things that are, I'm being super vague here. They're going to be able to write and draw things based off of data that exists out there. But at the end of the day, it's only really going to be kind of a general representation. You can ask it to do certain things and give it certain styles and things like that. Like you can have it, write like J.K. Rowling or something. That may or may not be how you pronounce her last name. But at the end of the day, humans are given a great degree of flexibility to be able to make decisions, be creative. So at the end of the day, some of these models can mass produce things very, very quickly, which may help people do their job. Mm-hmm. But at the end of the day, humans can go in and maybe fine tune, or maybe it can basically make you a rough draft of something, right? And then you can go in and fill in the blanks and kind of copy edit a little bit. Mm-hmm. So a lot of the times, people are worried that that's going to totally replace their job. I wouldn't necessarily see that as a possibility for quite a while, just because of the thing that we just mentioned, as well as the amount of compute power that it takes to run these algorithms. Of course, there are companies that'll make it easier to access. English is hard. That's when the bot will replace me. There are companies that'll make it easier to access those. But at the same time, you'll still want to be able to work with people to be able to fine tune some of the kind of rough drafts that get put out.
Awesome.
No, go for it. It's just fascinating.
Yeah, I know. So again, touching upon something that we touched upon a little bit with biases. So question for both of you: what tips from the AI ML side do you have to help people who are creating this technology limit biases? And then you touched upon it a little bit with how we do it in design. So if you have any further tips, I'll open that up to both of you.
Sure. So your question was about eliminating biases in like the experimentation process or the...
Yeah, not automating the biases over and over.
You're good. Yeah. So at the end of the day, you want to just ensure that your experiment is created in a way that should offset those biases as much as possible, right? Like you shouldn't just like take a data set and then feed all of it into the model and just say, I am pretty sure that this data set is outstanding and that everything is perfect. And we're just going to feed everything into the model because, there's that whole saying about garbage in, garbage out. And without reviewing the data set, the whole point of AI/ML is that you want to be able to create something that works against the vast majority of the population. And population in this case being what it sounds like, everything that exists in the world based off of a small sample. So you want to be able to, from your sample, have something that represents as much of the learning space as possible. So you're taking a small number of data points, you're taking a number of data points that represent a very large learning space, but you want to make sure that everything's at least relatively evenly represented, because otherwise, if you have an example of only, let's say you're trying to detect dogs versus cats, right? And maybe you only have golden retrievers labeled as dogs. What happens when it sees a terrier? Right?
Yeah.
It's going to be like, I don't know what that is. Is that a rat? But not offending.
Just option 3.
Yeah, not trying to offend terrier owners. So when we're creating these experiments, we want to ensure that we have representation of all groups as much as we can. And if there were, for example, not a great number of examples of specific, instances, like maybe we didn't have any pictures of terriers, let's go out and get some, right? Or make some, because we can, in some cases, use some techniques to essentially augment the data set with some synthetic data, where it'll at least look close enough where the model hopefully will be able to figure out what a terrier is and not be like, again, rat.
Oh my gosh, that reminds me of, there's a kids movie on Netflix. It's like I forget what it is, but the family is like on a vacation and robots are taking over the world because the cell phone takes it. And their dog, I forget what the dog is, but the robots are trying to identify it. And it's like, duh, 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 duh. Do you know what it is?
Yes, I know the scene you're talking about.
Yeah, it's like some kind of dog type. Bread, pig, blah, blah, blah. And it like basically like breaks the robot because it can't identify the dog. Because to your point, they didn't put that type of dog in their program.
No, I did see that.
Yeah.
Surprisingly good movie, but
it's really entertaining.
I did find that funny.
Sorry, tangent.
No, it's great. Did you want to add on any tips for eliminating bias?
No, I think I covered them earlier. I did have a question, and maybe I'm like trying to connect it to my world of UX research. You were talking about like you take a segment to represent the larger population. It sounded very similar to, we'll do user interviews or usability testing, and we can't interview, say there's like 2,000 people that use your product.
Yeah.
Can't interview every single one, but we take a segment of folks, and there's not really, it's at least 5 people. It depends though, right? But so is that similar with what we do with UX research of trying to get, like, it's a small segment number, figure out the best number for what you're trying to do, and then you're trying to represent the patterns that would help improve the 2,000 users of your product?
Yeah, so I know that when I talk about, AI, machine learning, data science, all that stuff, it can sound like I'm talking about some crazy mystical thing that, we're sitting there with like a computer equivalent to a crystal ball and we're figuring out what's going to happen, right? Those same research methods that you're using on the user experience, human HCD side of things, those research methodologies still apply to data science, AI, ML, because data science, AI, ML, all of that is in some way, shape, or form built around statistics, calculus, linear algebra, a number of different mathematical practices, all built around these research methodologies that have existed for an extremely long time. And at the end of the day, a lot of those techniques, and maybe I'm going off on a tangent here.
It's okay. That's great.
But a lot of these techniques have been around for a very long time. The only reason why they're making, well, not only, but the main reason why they're making such a huge impact now is that we have advances in compute power that allow us to do this now at a much larger scale than ever has been, leaning back too far, than ever has been done in the past. Yeah. So yes, it's similar, if not the same.
Nice. I feel like that was like a helpful, like, what's that called? When like you can relate to things that aren't, well, I guess this is similar.
Analogy? Or?
Thank you. Yes. Thank you.
I'm not a languager, but I try.
You're on it.
So AI in the media, what positive ways has AI/ML been represented in the media?
Sure. Silicon Valley. No, it's love Mike Judge as a comedian and or writer. But so I guess the positive ways that AI ML has been represented in the media. I think that there are definitely, I guess I'm like stumbling here a little bit because, there's both sides, right? On that side of the house where it's like, there are good things, there are bad things. Like,
Don't worry, I'll ask about the bad next.
Sweet, sounds good. All right, I won't get ahead of myself then. So positive things out there, there are things like cancer research that are, being able to take advantage of AI ML techniques to improve, faster diagnoses and assist doctors in being able to identify cancer in patients, with especially early detection, things of that nature. There's one piece that I recently saw where it's augmented reality glasses that display subtitles on the glasses as someone speaking through an app in their phone.
Oh, that's cool. Wow.
And so it's able to help people that are hard of hearing or hearing impaired interact without having to sit here and stare at you and lip read because they can look wherever they want. They've got subtitles now. They don't have to lip read. So that's something that I think I just saw the other day. I don't know when it was necessarily originally published, but there are ways that this is able to help people that, maybe we could have done, if we had a large machine in front of us before, but now with the compute that's available just in our pockets, we're able to take advantage of that and, make people's lives at least a little better. And then, probably a lot better. And then on the other side, just straight up saving lives with things like cancer research.
Yeah, that's cool. I'm excited for your bad question.
Yes. So I'm very excited to ask this question. Are machines going to kill us?
Not yet.
Not yet. See, everyone laughed that I had these questions.
Oh my.
Yeah. So when we're thinking about like, is AI ML dangerous? Like, yeah, of course it can be, right? If we were to sit there and put, the same thing that would tell you if someone's like going into your base, if instead of just a camera, it was a camera with a gun on it, right? Like, it's now suddenly more dangerous.
Yes.
There is a guy who built the same thing for squirrels where it just fires a little water gun at them, not an actual gun. But he would have it detect when a squirrel would come up to the bird feeder and it would squirt the squirrel off of the bird feeder.
Oh my gosh.
So, there are ways that you could apply it where it could be dangerous. But I'm pretty sure that like breaks international law or something like that.
So my next question where this is actually coming from is like, again, with the media, like looking at movies like iRobot, we were just talking about Smart House.
The Disney movie.
Yeah.
It was like before its time.
Exactly. So what, basically like how are humans and robots going to be able to interact in a safe environment?
Yeah, for sure. And at the end of the day, that's like one of the areas we talked about, the human in the loop side of the house. For example, there's the Zillow trading algorithm debacle that I think everybody's pretty have you heard of that one yet or no?
I have not, but I spent a lot of time in the car this weekend, so.
Well, so this was during the house price inflation that's happened over the past year or two, where Zillow has obviously a pricing algorithm to estimate the price of a home, and they gave, if I recall correctly, pretty darn near full autonomy to that to be able to determine whether a house should be purchased or not. And then they would purchase these houses in bulk, go in and, fix them up a bit, and then go out to try and sell them. Well, it turns out that didn't necessarily work. because one of the things that was driving up house prices were, people looking to buy low and flip and sell high. So once you've already flipped and sold high, you have that high inventory of redone homes. There are less people that want to buy those, more people that want to buy the fixer-uppers. So, I don't necessarily need a backsplash in every, room in my house.
You don't?
Yeah, what? I'm sorry. Don't come for me, HGTV. But
no accent walls for you everywhere.
I just saw that wallpaper is making a huge comeback for 2023.
Is it? I gotta take notes then. But yeah, so at the end of the day, we want to keep humans in the loop because if we just completely leave AI/ML unchecked, there's still some sort of flaws that exist in the system. There are things called like model drift where things change over time. Model drift is a concept of like, if you trained an algorithm to determine what a car was back in the 1960s, a car in the 1960s looks very different from a car in the 2020s. So if you were to show it a Lambo, from today, or even a smart car, right? Yeah. And it's basing it off of the kind of boxier build that existed back then. It might have trouble determining what a car is. And so what you do is to deal with model drift, you have to retrain these models. You have to identify when they start to kind of diverge from reality and start to get things wrong a little bit too often and figure out why. And if you can't necessarily get to why, at least figure out like, what's the commonality that it starts to get wrong? It's like, oh, maybe it hasn't seen enough of the new 2023 Volkswagen Beetle or whatever. Something of that nature. So we just want to try to, to ensure that people and robots work well together. We want to make sure that we're making sure that those robots are, correct over time. And that's where the humans come in, right?
Yeah. Nice.
Awesome. So we're going to switch gears a little bit off of the robot talk and more into when you're on a team and a cross-functional team and bringing on a data scientist. Do you have any tips for sort of how you bring on a data scientist? And I mean, just from this conversation, your role is very vast. Like you can touch on a lot of different things. So what tips do you have for those wanting to bring on a data scientist?
Sure. So, even talking about the stuff that I do is just a fraction of what exists out there, right? So when we talk about data science, the entire field is massive. There's everything from descriptive analytics and building BI dashboards all the way out to dealing with like reinforcement learning, which is when you have like an autonomous robot trying to make decisions for itself. That's the Deep Blue, the chess playing robot from back in the day, or OpenAI having its robot hand try to solve, like, I don't think it's solving a Rubik's Cube yet, but it's like flipping a cube to figure out its direction. Anyway, so when we get into bringing on a data scientist to the team, it really depends on the level of that data scientist, right? And also how familiar they are with your problem space. So if we're bringing someone onto a project and they've never worked with a certain kind of model architecture or, some sort of, like, if whatever area that we're working in is new to them, we want to give them time to ramp up, right? We don't want to just be like, day one, do it. Don't explore the data, just do. We want people to be able to get accustomed to what it is that they're coming into, understand the data, the problem space, what we've done already, so that they can come in and deliver value as they get familiar with it. The other side of the house is, if you're bringing in someone that's, maybe a fresh graduate or something along those lines, allowing them to start small, essentially, and start to build up their understanding of the things that you've done and are working towards by examining and improving on maybe some past experiments, things of that nature, or even just giving them the opportunity to train and develop themselves, because there's a lot to learn in this space. So we want to ensure that people are able to take time to learn new things that either interest them or are, the things that we're specifically driving towards. Because a lot of the times innovation comes from, as someone's learning something new, they're applying it to something that they already know. So as long as you're given time to learn new things, you can keep on, delivering that innovation to your team.
Awesome. And then without going into too much sensitive feedback, can you let us know at MetroStar what you and your team are working towards with AI and ML?
Sure. So we're right now working primarily on building out our practice to include some reproducible AI ML environments. So that's something that we already did with a couple of our clients, enabling them to take something from one area and reproduce it in another, with a very strong level of parity. So what that means is, if you run an experiment in this computer and then you pick all that up and move that experiment to another computer, you're going to get the same results. It's not going to tell you that cat is like a, Guatemalan ferret or something. I don't know. It's, it was just a relatively random example, but so we're working towards being able to do that, as well as some things around model deployment and things of that nature. Because once you're done with the experimentation process, it's great that the data scientists and all the engineers can work with it and make it work and everything. But then opening it up to the public, and when I say public, I mean like the end users, and then allowing them to go in and get information from that model, and then on top of that, the human in the loop side of things, send back corrections to the model or just give feedback on its performance and be like, good job, buddy. We love those good job buddies, as well. Make sure that we're putting, good ML vibes for the model or whatever.
Awesome. And then before we do our wrap up questions, I have one other question for you. How would you say UX people and data scientists can work together? And Marie, if you have input too.
Yeah, so the UX side of the house is super important because at the end of the day, and I would even expand that out to HCD in general, where we're with data science, machine learning, AI, we're trying to solve a problem. We're not building machine learning for the sake of building machine learning. Typically, we're working towards solving something. A lot of the times we'll start with a problem, and then we'll know we've got access to n number of data sets, right? We want to try and figure out how to solve that problem, and there can be some experimentation over here, but we're typically working towards something in the view of how do we help, person that we're working with get to where they want to be. And so when we're working on the HCD side of things, it can be really great to be able to work towards understanding why that problem exists and how our solution actually solves that problem or not, right? If we're working towards something that we as engineers are like, oh yeah, this is definitely going to work, but then the end user's like, that's not what I need at all. We already do that, right? It's then we waste less time by working with someone to understand that actual business problem at the end of the day.
Yeah, no, I think Wilson covered it.
Awesome.
Well,
and
sorry, took me a while to say the last word.
No, go for it. So we have some wrap-up questions for you, if you're cool with that. Okay,
yeah.
Cool. So can you let us know what events you would recommend to our listeners, as well as can you let us know any social media follows so people can find you?
Sure. So I'm obviously on LinkedIn since I used to work there. And I'm legally obligated to keep a LinkedIn. No, I'm
No
kidding.
way.
No, I'm joking.
I was going to say, wild.
They show up to my house. Not
It's like
actually.
a binding contract for life.
I have a chip in my brain.
AI in action.
There we go. So, so we do our PyData DC meetings once a month. I know we've got one coming up January 5th with Travis Oliphant from Quansight and Open Teams. We'll be doing this, this series of events for PyData DC, throughout 2023.
Can you let people know what PyData DC is?
Sure. So PyData DC is a group of people that get together to talk about nerdy data stuff, right? So as we want to try to learn new things, it's a place for everybody to get together and share stuff and really network at the end of the day. And also get to see people talk about cool stuff, right? So, that'll be, the one in January will be great. Travis and his team are really awesome. He's the founder of Anaconda, NumFocus, creator of NumPy, SciPy. For anyone that's familiar with those packages, they're super important in the data science community. So he'll be going into a little bit about how Python came to dominate the AI/ML space. Outside of that, we kind of do a lot of things. So I tend to post those on LinkedIn. So anyone that wants to connect and check out other events that are going on, I like to keep those going.
And then, sorry.
I just said cool.
Oh, gosh.
Sorry.
No, sorry, I'm cutting you off. For those who may be new to the data scientist field, or they are dipping their toe in, would you say it's an open environment for them to also join all levels of expertise?
Yeah, we're not exclusive or anything like that, where it's you have to have 2 years experience
Okay,
before you can do it.
perfect.
Yeah, if you're even just curious and want to understand a little bit about what's going on, feel free to come in. We got people of all levels.
Awesome. Great.
Yeah.
Thank you so much for joining us. This was very informative.
I'm glad you all had fun, and thanks for having me on. I appreciate it.
Yeah, thank you.
Yeah, thanks for answering our questions. And with that, this was Mock It. Don't forget to like, subscribe, and share with your friends, and join us next time. If you're interested in learning more about how government and tech collide, visit metrostar.com and follow us on our socials.
Have you ever been in an interview with someone and you're like, so have you checked out the website? And they're like, no.
I've had them actively say yeah, I read about all the stuff you guys have done. I was like, cool. So what got you interested in
just everything.
Yeah. And
you guys are amazing.
good, man.
At least they tried to fib it.